review kind of what we talked about with like lists versus dictionaries, and then review this LeetCode problem. All right. So just remember, like what with lists, and what are kind of like the benefits of them. Essentially, just remember that with lists, what we're doing is we're storing, where does the list begin? So if we declare a list, have like A, B, C, we have, that this maybe begins at in memory, right at location 100. And then we make sure when we declare a list, we're allocating like a fixed block of space, right? So that if this starts at 100, we make sure we evenly space out our elements in terms of where we're storing them. So this will be at location 108, and this will be at location 116. And what that allows for us is fast index-based retrieval. So if we do array of 0, 1, 2, we just have to use the formula 100 plus 2 times by 8, right? Where 2 is the index. And if we do, at 0, it's 100 plus 0 times by 8, right? Leads to 100. Okay, so that's very fast with a list. What's slow with a list is like checking inclusion, meaning checking something like, is A in the array? Why is that slow? I mean, relatively slow, right? What's the cost of that? O of n. Because we have to essentially go one by one. And then what can make that faster is sorting it. Okay, so we can sort it, but just remember if I do sorted of the array, that costs n log n. Okay, and then from there it's a little faster because we can use binary search to see is something in the list or not. All right, but sometimes they might say like they don't want you to sort. It has to be in. They don't want you to sort it. There can be various constrictions, or you come to the solution and then they say, can we optimize it? So it's still very important to know what are the costs of these operations. And so what can you use for like kind of inclusion to see is this thing in the collection? Instead, you can basically you can hash the elements. So there's different ways to do that, right? One is just simply use a set. Right, so you can just do set of the array, and this will be, one, we know that set gives me a unique list of elements, but the other thing is that if you want to do something like check for inclusion, and say, is the element in there that, like, is A in this unique list of elements, right, that only takes one operation, big O of 1. Okay, and why is that? It's because when we create a set, right, the other way of doing it is you can just, do like this, A, B, C. When you create a set, right, it's applying a formula here so that it takes this and it hashes it, right? It takes the letter A. It's going to pass this through a hash function, right, and this will spit out a location memory. And then when you ask the question, is A in the unique list, elements or in the set, it passes this letter A through the same hash function, gets the location, right? And then just looks there. And if there's something there, it gives you a back, right? It says yes. If there's not something there, then it says false, okay? The same thing happens with a dictionary, right? With a dictionary, these things are just keys. And A is for apple, B is for bear, C is for cat. So with a dictionary, it's the same thing, right? So when you go, these are my objects or something, and you do objects of A, this goes to the hash function, the letter A, that spits out a point in memory, and then in that point in memory lives, right, whatever the value is, or really it's like a pointer to whatever that value is. So it would be the word apple. and it just returns this to you. So then when we go try to retrieve it, it'll either return for you apple, or it will go there and give you that key error, right? There's nothing located there. But either way, think about how many operations it takes to, to see, like, is there a key of A in this set, or sorry, in this dictionary? Just one operation, right? Employ the hash function, go to the hash function tells you what location to go to, and then you either return the value or you say there is no value there. All right. So this can kind of give you an idea of, like, when you're checking for, inclusion, right? Is this thing in there? You want to try to use either like a dictionary or a set where possible, right? Again, you don't have to always start that way. Like, I won't always start that way unless it feels like reachable. I feel fairly comfortable with it, or it really depends on kind of like the nature of the interview. But this is like what to reach for. All right, questions about this? So then the next thing we can get to is this longest consecutive sequence problem, which is here. So this is, okay, given an unsorted array, which array is just the same thing as a list, of integer numbers, return the length of the longest consecutive element sequence. Try to solve the problem. As a bonus, try to solve it in O of n time. So if it's, if I'm just solving it, probably what I would do is, the easiest thing for me would be to sort the numbers. And then you can already, by the way, I want to and now I can just start to, go to the next number, right? Kind of go to the index plus 1, right? And if it's one bigger than the previous number, keep going, essentially. Or I could probably even just loop through these numbers, right? And then as long as the next number is the same thing as the previous one, right? Plus 1, keep the counter going, right? So you can kind of so that's what my logic would be for I in range, which means that I want to, because I want to look back or look ahead, I want to use the index, right? So I want to not just normally loop through it, but probably use the length of the numbers. And then you can just kind of do the nums. This is the current number. We'll just print I, and then print, nums of I, and then print nums of I plus 1. Okay. And for I in range. Oh, and then I have to stop. Probably what's going on here is I'm going. This is I plus 1, so I'm getting out of the range because, because we're 1 greater than the index, and this has to be my sorted numbers. That's why it looks so weird. Okay, so you can start to see, this is nums of I is, this should be sorted nums again here. So it'll start to look a little better. Yeah, so you can start to see, that here I have, just to make this a little bit nicer, here we have, my 1 versus my 2 versus my 3 versus my 4, and we can, increment this each time. Is kind of set up a counter and then increment it each time if they equal one another. So that would be one approach. The other approach, because again, this sorting costs n log n to do this, another approach that I tried to work through was using a set. This one I will code all the way through. This one I haven't done before class. I'm a little nervous going through it live coding. But the other way that I approached doing this was trying to use a set, right? So how would I do something like this? So the first thing I would do is set these numbers. Okay, so I'll call these my unique numbers. All right, and then I'm just trying to solve this. So basically what I'll do is I want a starting number, and that would probably be my, this number 1, So I want to start at the beginning, And essentially my approach is going to be like, so start with a low number, right? Meaning beginning of the sequence. Potential sequence. So that would be like, I could kind of ensure that if I do min of the unique numbers, this would be my first num. All right. And then from there, I want to see if the next number is in my unique numbers, right? Then I want to kind of increment a counter. So I can maybe set a counter at 1, and then if the next number, or what is the next number? The next number is my first number, right? First number plus 1 equals my next number, all right? So you can see I'm starting to like implement, we're starting to get to this logic. So, okay, so we have a counter. If the next number is in the unique numbers, we can do counter plus equals 1, right? Because now this streak is increasing. And probably the next thing I can do is remove this next number. So if next number in unique numbers, then I'll do unique numbers dot remove this next num. And that's starting to be pretty good. We're going to have to consider the else situation. Okay, so this is, you use the remove method when you're working with the set. And now the next thing I kind of want to think about is, okay, if the next number is not in there, then what I want to do? Well, I want to basically start over my streak. Okay, so I want to set my counter equal to 1. So you can kind of think about this. Sorry, before I just move ahead, we'll just want to make sure everyone understands. So we're going to start with our first number. First number, let's say, is 1, right? Then I'm going to say the next number is going to be, right, like a 2. If the next number is in there, then we're going to increment the counter, and we're going to remove the unique numbers. We could also, we'll probably also want to remove that initial first number too, but I guess maybe for now we will do that. All right, so I'm just kind of like working through my logic at this point. I can always refactor that, and that's what we will get to. But you can see I'm just like kind of like coding out my logic. All right, so then the next thing is, well, what if we kind of like, we get to the end here, right? And now we want to start over. So what should we do? Well, we want to reset my counter back at 1, all right? I need to reset my first number as my minimum of what's remaining, okay? And then, yeah, we could do this next number thing again too, right? So first number, this is the next number, is that, and we should also remove the number. We should remove this first number. Okay. So let's think about this. We start with the first number. And let's say the first number is the minimum existing. If the minimum is there, right? If the next number is there, then we'll increment our counter and remove that next number. Okay? And we can kind of keep doing this, and then we want to do this again, right? If the next number, calculate the next number. If the next number is there, then remove it. And now I'm going to start to, I want to keep doing this, so I'm going to say while there are unique numbers, I'm going to keep doing this. And now I'm starting to I feel like I'm starting to get there. Okay, so the other thing I want to probably do is actually increment, let's see if I can explain this well. There's going to be when I get to the next, think about this, we start with 1, let's say I set my next number as 2, I'm going to remove it, right? But I'm not incrementing my next number, so this should actually probably move here, where the next number equals the next number plus 1. And now we're actually starting to like set this up. Sorry, this is a confusing example to explain, but I think you'll kind of see where my logic arises. So we can kind of think of this. You kind of start with this initial number. We need to calculate the next number somewhere, because right now you can see if I go through it the first time, it's not going to be defined anywhere. So I can just set next num to something arbitrary like negative 99. And now let's think about what's going to happen. We start with our minimum number. It's going to be 1. Next number is negative 99. Negative 99 is not going to be in this list, right? As long as we have parameters, we could always do negative infinity. So then we'll go down to this situation, all right? So it's basically what I'm doing is I'm setting up my base case, right? And then the counter equals 1. So we'll start the counter at 1. We'll remove that first minimum number, which we could actually put right here. Remove that first minimum number. And then we'll calculate the next number. All right? So then we'll get to 2. So that's this first number plus 1. Then we'll get to 2. If 2 is in the unique numbers, increment the counter, right? Remove 2 from the list, and then increment the next number. All right? So you can, I know this was right, like a roundabout way of doing this, but it is this procedure of I'm kind of setting up my like main logic here. Then I'm thinking about the case that there isn't a sequence, right? And then the next thing I'm doing is I'm realizing, all right, this case where I'm like restarting my sequence is also essentially the same thing as me just initializing this whole procedure, okay? So things that I don't really, as long as I make sure that I'm setting my next number as something that, in this first case doesn't exist, this else block becomes my first time ever running this procedure. So what that means is like I don't even need this step. Sorry, I'll just show you what I'm deleting. I don't even need this step or this step or this step, right? Because the first thing that's going to happen is it's going to see there is this, not this next number. So we're going to go through here, and that's, this is all repeat, right? Set the counter at 1, set my first number, remove that number, set the next number. Now see, is the next number in the list of unique numbers? It is. Increment the counter, right? Remove it, remove that next number, and then increment this, right? So now see if the number 3 is in there. It is. Increment the counter. The last thing we want to do, this is fine. The last thing we want to do is just remember this counter, like I need to keep track of, here I have a streak of like 4, and then it resets, and I need to keep, and it goes down to 2, right? This second one is, 2, a streak of 2. So I need to keep track of like the global streak. So we can just declare something here called like global counter and set that equal to 0. And then basically say something like global counter equals the max. Remember this little trick? The max of the counter, comma, the global counter. And I think this is it. All right, so this works. So this is 4, which makes sense because it's 1, 2, 3, 4. All right. So just to like, I think let me just run through the code and then I'll run through again how we did it. So the code is basically saying while we have elements in the set, if the next number is in there, we want to increment the counter, remove it, remove the number, and then see can we keep the streak going, right? So the next number plus or equals 1, okay? When there's not a streak going, or when we're just first kind of starting out, we're going to go to this else block, okay? So next num, we purposely set at a value that can't exist. So that means we start our counter at 1, right? We start from the beginning. We find that unique number, the first starting number. We remove it, and then we look for the next one. And now, if we have a streak, right, we're caught in this, okay? Then the final thing is just my global counter is the maximum value between my counter and what we've already had, right? What we've already set at this global counter, right? So this works fine. The only other thing I'll probably refactor to this is just next number equals plus or equals 1. It's not any faster. Questions before there is a more optimum solution than this, just slightly, which I can show you. But just questions before we potentially look at that. So this is the code, right? And just remember, how did I solve it? Like I said, it's a little, I know this might have been confusing. It's because I also wanted to show you my approach. My approach is to really just spell out my logic for a streak, and then I worry about kind of like, all right, how do I initialize this? What do I do in the other scenario, right? But really all I did was just kind of move step by step of, okay, what do I have to do if there is this kind of streak that's going on? Okay, is the while loop O of n if next number in unique? So the while loop will only go through these, we're going to be removing a number essentially each time. So this I think is okay. So if we remove one, how many times will this happen? Either way, we're removing a number, So this will only happen n times. The unique numbers, the setting of them, when we do like set, this also occurs, this is also a cost of n. So we're okay here. In both cases, we're okay. Where we are not actually okay is with this part. Okay, because a min, if you think about it, so if you just have to think through like what are the operations doing underneath. So here we have to still go one by one through every element of the list, right? So that, and like allocate it to a location in memory, like what we were explaining up here, right? We have to call this hash function to allocate each element to a location in memory. So that costs n. So that, right? So this initial thing costs me n. Then this while loop also will essentially, it would just cost me n. The problem is that I have this min. The min function is itself, you're going to have to sort the elements in the set. So this is n log n, all right? And this is, and I'm doing that basically every time there's we're starting over my streak. So it's potentially, this potentially can be expensive because it can be n times doing n log n. This is actually n squared because of this min thing. So if you look at like the official LeetCode thing, right? Like you probably, if I was on an interview, they asked me then to refactor it. I have the solution. I'm just going to show you what they get into. They do it this way. It's similar to what we did, but what they do instead of the min is, so they first unique it, right? They call this streak instead of, like this is my global, this is like that global counter, right? They do use a loop, and basically what they say, instead of using the min, they go through each number, and they see, instead of using the min to see if it's the start of a sequence, they say, is the previous number, is there a number one less, right, in the list of unique numbers? If there is, skip it, right? Only in the case where, and go to the next number, only in the case where the number is not in there, right, that there is not one less, meaning I must be at like this number, right, then that's going to be my current number. Now I'm kind of beginning the loop. Set my current number equal to 1, set the current streak equal to 1, while the current number plus 1, right, is in the list of unique numbers. So this 2, right, increment the current number is now 2, plus equals 1, increment the current streak, then we look, current number is now going to be 3, increment it, current number is now going to be 4, increment it, right? And then we get to like, as we loop through the number, like what we haven't removed any numbers in their solution. So as you loop through the numbers, maybe we get to like the number, you can imagine getting to the number 4, right? Like, but it's not going to pass because num minus 1 is there. So you would skip 4, right? If you got to 3, you would skip 3 because num minus 1 is in there, right? Because 2 is in there. So you would keep looping through these, and it would only be when you got to like a 1 that you would actually, or you got to this 100, 200. But for a streak thing, it would only be when you got to a 1 that you would start incrementing this and actually calculating your streak. So you're going through one by one these numbers for the number in the set of unique numbers. If we're in a streak but not at the beginning of a streak, skip it. Then if it looks like there is no like 1 before number, like it's not 2 and there's a 1, then we kind of begin our procedure. All right, and then this is the same thing. If the next number is in the list of unique numbers, then increment it and also increment the streak. What I would do is remove the number from the set. That way I don't have to, right, like go through the list of all the numbers here and then go through them all, potentially go through 1, 2, 3, and 4 again, right, which is what they're doing. So what I would do is do something like unique nums, remove this, and I would do it up here, I guess, current num. Okay. Let's just go through the procedure so we can understand what happened. We start with the number 100, right? For number in unique numbers. Start with the number 100. If this number minus 1 is not in unique numbers, right, 99, then set my streak, set my current number to be 100, set the streak, that equals 1. While current number plus 1 is in unique numbers, 101, is that in unique numbers? It's not. So we're kind of done at this point. My current streak is going to be 1, right? So my longest streak is going to be 1, and we start over. Go to the number 4. If number minus 1 is not in unique numbers, it is. So we're on to the next number. Go to the number 200. Is 199 in here? No. Current number is 200. Current streak is 1. Is 201 in there? No. Now we're on to the streak, right? So now we have 1. If number minus 1 is 0 in here? No. Current number is 1. Current streak is 1. While the current number plus 1, 2, okay, is in the unique numbers. So it just takes 1. This only takes a O of 1, right, because it's a set to look this up. Then remove it. We can remove this number 1. We don't have to look at it again. And we can increment this to 2. All right. And then we can perform this again, right? So current number is now 2. Is the next number in there? 3, yes. So then remove the 2, increment it to 3, right, and increment the streak. So you can see this logic. Effectively, the main trick they're doing is they're using this they're just, instead of using a min to see are we at the beginning of a potential streak, they're using this num minus 1, and then they're saying just loop through all of these and do the sequence, right? Move through the sequence, but only move through this sequence if we're at the beginning of a streak, meaning there is no previous, 1 before number. All right. So this is kind of like how I would have started. I think it's easier to it just maps the way I would think through it, and then we could deal with this, getting rid of this min problem, which is what they're doing down here. All right. If this next number is in here, increment the number, increment the current streak. Okay? And they have to loop through all these. Anyway, try to solve it. It would be good if you could solve it at least this way. It would be even better if you can kind of follow this logic and solve this too. All right? But I think one of the main points is your logic would probably be, your first intuition would probably be, oh, this is like a list. We care about sequential numbers. Lists are excellent at ordering things, and so let's just order the list and like move through that first approach I was showing you, but this can be turned into this ordered list. Seemingly, this ordered list problem can be turned into like an is this element in the list problem, right? And include, checking to see is this thing in the set or in the list, and therefore if it's that, then we can prefer a set, and we know that sets, we can avoid ordering the list, right? That's kind of the goal by moving towards a set. All right. So yeah, I know this. This is why you kind of just have to code these out. Sorry, it's a little hard to explain, but hopefully this helps a bit. The next thing, we don't have to talk through this. We've talked about. I'll deploy the solution here. We've talked about histograms enough that I'll deploy these. You definitely want to practice these, and then go through this two-sum LeetCode, and I wrote out the solution for you too. All right. Even though I know you've seen two-sum, what they're asking you to do is show the index, right? The index of the values that say add up to the number 7. So in this case it's 2 and 5, right? So 0 and 2 are the indices. And, that's a little tricky, right? So that's why it's worth looking through this solution. If we can, we'll get up to recursion today. If not, we'll cover it next week. All right, but I'd like to get up to recursion today. All right, so I'll deploy these. These might just be easier to move through yourself than for me to explain them. But feel free to ask me or Wayne questions, please, if you have questions about these. All right. So I'm going to deploy these. And then we still have to get back to SQL. We will do that pretty soon. All right. I'll move you into breakout rooms.